Hello, Mr. Sargent's Math 2 courses. Want to thank you again for finding my course here through Google Classroom. And again, please watch this video. At the end of this video, answer the questions on the Google form below. They should be due by the end of the week, which I believe is April 24th. In the previous video, I might have incorrectly said April 25th, but Friday, April 24th is the deadline for these videos. A couple of things I'd like to point out. Still got my hair clip. And check it out, it's springtime. Take a look at that spring tie. Oh, who couldn't be excited? I'm definitely excited. I'd like to talk a little bit about some things we saw right before school closed. Notice that we're going to continue using SOHCAHTOA, but this time when we have an angle called theta, when we don't know our angle, we're going to use the inverse functions. Now we begin the problem the same way as previously. We label our reference angle with an I. The I sees opposite. 12 is the hypotenuse, and the remaining side is adjacent. Now there is no value on the adjacent side, so we will not be needing it. We want hypotenuse and opposite. To me, that looks like we're going to be using a sine. So we're going to say that the sine of theta is equal to opposite over hypotenuse. Now remember, when we don't know the value of our angle, this is when we use our inverse function. Now the inverse of sine is this sine with the -1, and we want the inverse sine of 5 over 12. Now everyone's calculator does this differently. You need to make sure your calculator is in degrees mode, not radians mode. So you're going to calculate the inverse of sine of 5/12. You might want to pause the video and you want to check. You should get an answer for theta should be 24.6 degrees. So go ahead and pause your video at this time. See if you can get 24.6. Ready? Pause. All right, hopefully you figured that out. Let's try a couple of more examples here. In our next example, I believe theta is in a different location. We have a leg that measures 25 units and another leg that measures 19 units. What we're going to do from here is we're going to label our reference angle with an I. The I sees opposite. Up here is the hypotenuse, and the remaining side is adjacent. Again, the side that's not being used is hypotenuse. It has no value. We're looking for opposite and adjacent. Opposite and adjacent is tangent, so we will say the tangent of theta is equal to opposite over adjacent. As previously stated, when we don't know our angle, this is when we use the inverse function. So the inverse tangent of 25 over 19. You punch this into your calculator, we should get a value of theta that equals 52.8 degrees. You can pause the video, punch that in, make sure you are correct. If you are getting these correct now, you should get them correct in today's Google form. Let's go ahead and take a look at one more example today. Our last example for today, theta has moved locations. We have a hypotenuse of 21 and a leg that measures 15.2. Now, as we did previously, put an I on the reference angle. The I sees opposite. 21 is the hypotenuse, and 15.2, the remaining side is adjacent. There is no value on the opposite, so we're using hypotenuse and adjacent. Hypotenuse and adjacent looks like we are using the cosine. So we say the cosine of theta is equal to adjacent over hypotenuse. Remember, we do not know the value of theta, so we need the inverse of cosine. The inverse of 15.2 divided by 21. We punch this into our calculators and we should get 43.6 degrees. Let me tell you something we did differently here at Golden Valley this year. We had a no phone policy that was being strictly enforced. And what I saw this year at Golden Valley was I saw a high number of students who were not relying on their phone as like a social backup. Instead of using their phone and hiding behind it, they were expressing their personalities, they were socializing, they were fun to be around. And I missed this year at Golden Valley being around all of those students who were keeping their phones put away and they were socializing and interacting, making my day fun for me. What I'm doing up here is a different kind of fun. I like working on the math and being a mathematician, but I miss being in the classroom and talking to people and hearing what you have to say and hearing your personalities. So I want to thank those of you who made this year such a good year. I will see you again next week. Make sure you check back for another assignment.